In this, we need to evaluate integral x square minus x dx divided by x power 4 plus 3x square plus 1. So first of all, we will call this as I. We'll call this as I. Now, what we will do, we will divide both numerator and denominator by x square. So it will become now x square minus 1 by x square in the numerator. Denominator is x power 4 plus 3x square plus 1 divided by x square. And then you have that dx. Now when we do that, numerator becomes 1, that is x square by x square is 1 minus 1 by x square. Whole thing divided by denominator. We have x power 4 by x square, which becomes x square, plus 3x square by x square is nothing but 3, and then plus 1 by x square. Now we will make this denominator into a perfect square. So how do we do that? We'll write the numerator as it is, and then denominator, we will consider x plus 1 by x the whole square. Actually, if we expand this x plus 1 by x the whole square, we get x square plus 1 by x square plus 2. So that 2 has to be subtracted. So we will put minus 2, and then whatever is written there already, which is 3, we will be writing that. So that means this I will become now integral 1 minus of 1 by x square dx divided by, this will become x plus 1 by x, the square plus 1. Now in this, let us consider, let t equal to x plus 1 by x. That means our dt will be 1 minus 1 by x square. I mean, if I differentiate x, it is 1. If I differentiate 1 by x, it is minus 1 by x square. So times dx. That means this I now can be written as integral dt divided by t square, and 1 can be written as 1 square. This is nothing but tan inverse of t. Tan inverse of t plus some constant c. Now we know t is nothing but x plus 1 by x, so we will write it as tan inverse of x plus 1 by x plus c. That is the result for this particular problem. In this, we need to evaluate a definite integral ranging from 0 to pi by 2 dx divided by 5 plus 4 times cos x. So we'll first call this as di, which indicates definite integral, which means our I, that is indefinite integral, will become integral dx divided by 5 plus 4 times cos x. Now we will be using one trigonometric identity, which is cos 2 theta is equal to 1 minus of tan square theta divided by 1 plus tan square theta. We'll be using that in the denominator of the given integral. So this integral will become now integral dx divided by 5 plus 4 times 1 minus of tan square. Here it will become x by 2 because here it is x. X by 2 divided by 1 plus tan square x by 2. Now let us consider let t equal to tan x by 2, which means our dt will become secant square of x by 2 times 1 by 2, and then dx. So further, when you have t as tan x by 2, t square will become tan square of x by 2. So here we can rewrite this dx as dx is equal to 2 dt divided by secant square of x by 2. Now, when we have t square equal to tan x square by 2, we have 1 plus t square will become 1 plus tan square of x by 2. 1 plus tan square of x by 2 is nothing but secant square of x by 2. So that means our dx will be rewritten as 2 dt divided by 1 plus t square. So that will be our dx. Now let us rewrite this integral in terms of t. So numerator dx, which will be 2 times dt divided by 1 plus t square. And then we have 5 plus 4 times 1 minus of this tan square x by 2 is nothing but 1 minus of t square divided by 1 plus t square. Now let us take LCM in the denominator. This I will become now 2 times dt divided by 1 plus t square. Here it will become 5 times 1 plus t square plus 4 times 1 minus of t square. The whole thing divided by 1 plus of t square. Now this and this gets cancelled. Now our integral will become 2 times dt divided by 5 plus 5t square plus 4 minus 4t square. So that will become 2 times dt divided by 5t square minus 4t square is t square, and this is 5 plus 4 is 9, which can be written as 3 square. Now this is a standard integral, so if we integrate it, we get 2 times 1 by 3 times tan inverse of t by 3. I am not writing plus c because the original problem is a definite integral. Now let us come back to this. The limiting values for x is 0 and pi by 2. So if x equal to 0, then t, which is, what is t? Our t is tan x by 2. So it becomes tan 0 by 2, which is tan 0. Tan 0 is 0. Then if x is pi by 2, then t, which is tan pi by 2, which becomes tan pi by 4. Tan pi by 4 is nothing but tan 45, and that is 1. So our limiting values in terms of t becomes now 0 to 1. Therefore, we can rewrite the definite integral as 2 by 3 times tan inverse of t by 3, and the limiting values ranging from 0 to 1. So this will become 2 by 3 times tan inverse of 1 by 3 minus tan inverse of 0 by 3, which is nothing but 0. So tan inverse of 0 is 0 only. That means the result will be simply 2 by 3 times tan inverse of 1 by 3. That will be the result. We need to evaluate integral sine x, sine 2x, sine 3x dx. In order to evaluate this, we will be using one trigonometric identity, which is 2 times sine A sine B is equal to cos of A minus B minus cos of A plus B. So in order to use that, what we will do now, we will multiply this integral with the numerator and denominator by 2. Means we'll call this as I. Now I can be rewritten as 2 times, 1 by 2 times, I will write 1 by 2 times Here I will bring in that to 2 sine x sine 2x sine 3x dx. Now for this we can apply that trigonometric identity, which will give us half times, or rather I will use this trigonometric identity for leaving apart the sine x. I will consider this and this and this too, which means we can rewrite it as 2 sine 2x sine 3x will become cos of, I will consider this as A, this as B, means 2x as B and 3x as A. So that means A minus B, it becomes 3x minus 2x minus of cos of A plus B. So 3x plus 2x. And then there is a sin x pending, so that we will write it here, sin x dx. So this I will become now half times integral cos of x minus cos 5x times sin x dx. Now, again, we will bring in one more 1 by 2 outside, so that I can bring 2 times sin x times cos x minus cos 5x dx. So what we did, we brought in again multiplied and divided by 2. So this becomes now 1 by 4 times integral 2 sin x times cos x minus cos 5x dx. So that is what we brought in. Now let us make 2 separate integrals. This will become now 1 by 4 times integral 2 sin x cos x dx minus 1 by 4 again integral 2 sin x cos 5x dx. Now we will use another trigonometric identity, which is 2 times cos A sin B, cos A sin B is equal to sin A plus B minus sin A minus B. To use this particular identity. So now our integral will become, integral is equal to 1 by 4, which is common, we'll keep it outside. So integral sin 2x dx minus this one, 1 by 4 is already taken outside. 2 sin x cos 5x will become integral sin 5x plus x minus sin 5x minus x, the whole thing dx. Now close again this. So this becomes now 1 by 4 integral, that is common, integral sin 2x dx minus integral sin 6x dx, minus or minus, it becomes plus sin 4x dx. Close the brackets. Now we can integrate all these things. This will become now 1 by 4 times sin 2x. If I integrate, it is minus cos 2x by 2. Here it is plus cos 6x by 6. This will become minus cos 4x by 4 plus some constant c. Now let us multiply this 1 by 4 inside. It will become minus cos 2x by 8 plus cos 6x by 24 minus cos 4x by 16 plus a constant c. That is the solution for this particular problem.